You want to build a heater that turns on when the room gets too cold. You've got a temperature sensor that outputs a small voltage when it's cold, so you try the obvious thing, connect the sensor directly to the heater. But it doesn't work. The heater needs a lot of current, while the sensor only provides a weak signal when it senses low temperature. So you realize you don't need the sensor to power the heater, you just need it to allow power to flow like a switch. Now, imagine this. You have two wires, but there's a block between them. Remove the block and current flows. But instead of removing it by hand, what if you could do it electronically? You know voltage moves electrons, so maybe you can use the absence of electrons, the block, as your control. Here's how. Take a piece of silicon with extra electrons, call that N-type, and attach it to a piece that's missing electrons, call that P-type. When you put them together, electrons from the N-type rush to fill the holes in the P-type. But they don't just keep flowing, they pile up at the boundary, forming a barrier called the depletion region. This is because once an electron fills the hole at the boundary, the negative charge repels other electrons from doing the same. Thus, no current flows through this region. Well, that's your block. Now, here's the trick. Add a third terminal, the gate, right above that barrier, separated by an insulator. If you apply a positive voltage to the gate, it pulls in electrons from the surrounding N-type regions. As more electrons gather, they form a conductive channel through the depletion region. The barrier disappears and current flows. The tiny voltage on the gate didn't power anything directly, but it controlled the flow of a much larger current, just like a switch. Congratulations, you've built an N-channel MOSFET.